Okay, so we have a couple more theorems. The first one we're going to cover is the complex conjugate theorem. And what that says basically is if there are any imaginary roots or zeros, it's always going to appear with its complex conjugate. And remember, the complex conjugate is where the imaginary term sign, or the imaginary part, the sign changes. So if 3 plus I is a root or a zero, that means its conjugate is also going to be a root or a zero, 3 minus I. And if you remember, anytime there was an I, it always appeared with that plus or minus, which is why they always appear as complex conjugates. Either it was through the quadratic formula that we got an imaginary number, or taking the square root of both sides. But either way, you always had that plus or minus. So it always appears as complex conjugates. So in this first one, given the roots of the polynomial -3, 2, and 1 plus I, find any other roots. Well, these two are not imaginary, so I don't do anything with those. This one is. Since 1 plus I is a root, that means that 1 minus I is also a root. And that's basically it. Any imaginary roots or zeros in the polynomial, its conjugate is also going to be a root. So for the second one, given the roots of the polynomial -1, 5, and 2i, write the polynomial in standard form. Now this is always going to be talking about the polynomial with the least degree. So since -1, +5, 2i, well, since 2i is a root, that also means that -2i is a root. Okay, and I need to write the standard form, but first I'm going to write the factored form. So I have x plus 1, x minus 5, x minus 2i, and x plus 2i. Always write, or always multiply out the imaginary factors first. Okay, this is going to become x squared, positive 2xi, negative 2xi, and negative 4i squared. The reason I tell you to always multiply the complex conjugates first is because the middle terms should cancel out because they're conjugates, and it stays a binomial, x squared, and then the I squared makes this a plus 4. Now you could do it from here a couple different ways. You could multiply these two together, you could multiply these second two together, and then the third one. Either way, you multiply two of them, you're most likely going to get a trinomial, and then multiply that one with the last one. So I'm going to do it here. X times x is x squared, negative 5x, positive 1x, minus 5, and I'm going to move up here. That simplifies into x squared minus 4x minus 5. I still got to multiply that with the x squared plus 4 though. So this is x squared times x squared is x to the 4th plus 4x squared. Negative 4x times x squared becomes negative 4x to the 3rd. Negative 4x times 4 is negative 16x. Negative 5x squared, and minus 20. Combine your like terms, which the only like terms I have are the positive 4x squared, negative 5x squared, so I'm left with x to the 4th minus 4x to the 3rd. Always write it in standard form. I got this one, then this one, then that is the x squared becomes negative x squared minus 16x minus 20. And this last one, write a polynomial function of the least degree with the given zeros of -1 and 5 minus I. Now understand, again, zeros is the same thing as roots. So since 5 minus I is a root, that means that 5 plus I is also a root. So I have the roots 5 plus I, 5 minus I, and negative 1. This one gets a little bit tricky because the roots are binomials. And when they're just monomials, like negative 1, all you do is x minus the 0. So x minus negative 1 becomes x plus 1. You still have to do the same thing with these. It's x minus, but it's minus that whole binomial. And then x minus, and that's going to be 5 minus I. So I'm still doing x minus the 0, or x minus the root. When I distribute this negative, though, it's going to become x minus 5 minus I, and x minus 5 plus I. Notice how this negative on the 5 is both a minus here, and that doesn't change. It's the sign on the I part that changes. If you start taking shortcuts and not do this step, that's a mistake that people will make. Okay, so be aware of that. So still multiply the complex conjugates first. X times x is x squared. X times negative 5 becomes negative 5x, and x times I becomes positive xi. Now I'm going to distribute the negative 5. Negative 5 times x is negative 5x. Negative 5 times negative 5 is positive 25. And negative 5 times I is negative 5i. And then here, negative I times x is negative xi. Negative I times negative 5 is positive 5i. And negative I times positive I becomes negative I squared. Now, because these are conjugates, what should happen is all the i's should cancel out. And if you notice here, I have positive xi and negative xi. Those two are going to cancel out. I have negative 5i and positive 5i. Those two cancel out. And now I can go ahead and simplify my like terms. Nothing's combining with x squared. The negative 5x and negative 5x becomes negative 10x, positive 25, and then I have this negative I squared, which is going to become positive 1. So I have x squared minus 10x plus 26, and now that's going to be multiplied still with x plus 1. So I have x to the third. Now that I'm distributing this x to each of them, x to the third minus 10x squared plus 26x, positive x squared minus 10x plus 26. That was distributing the 1. Now I line these up vertically this time with their like terms matching. X cubed minus 9x squared plus 16x plus 26. This is my polynomial with those roots. Alright, so for this one, I have 1 plus 2i is a root, so that means 1 minus 2i is a root. These are their factored form, x minus each root. I distribute the negative to each of them and multiplied them out. The red is I multiplied these two complex conjugates first, and the red is distributing the x. The purple here is distributing the negative 1, and the green is distributing that negative 2i into this last polynomial. The i's all canceled out. Positive 2xi, negative 2xi, negative 2i, positive 2i. So I get x squared. These two combine to be negative 2x, and then the positive 1 combines with this becomes positive 4, and that becomes positive 5. So then when you multiply those two out, you end up with all these terms. Combine your like terms and x cubed minus x squared plus 3x plus 5. So I got a good joke for you. What kind of music do mummies listen to? Rap music. Ah, they're all wrapped up.